Hello, geometry students, and welcome to our first lesson on rotation. Today we are going to be looking at the beginning of rotation and, more importantly, the notation for it. So we're going to kind of work this in three different parts. How do we look at the notation? Then how do we find this magnitude? How do we tell how far something is rotated on Thursday? And then we'll start to draw the different rotations on Friday. And in order to get this started, we've really got to take note down here. A rotation is the turn of a given magnitude, which is the amount of turn of our pre-image, that it rotates about some center of rotation. Okay, so it's going to be important that you take notes on the formulas or the notation that we use for rotation and how we go about finding some of these different pieces of information, these different notes, if you will. So here is the notation for a reflection. First, we have a capital R, right? Reflection was a lowercase r, now we have a capital R. And this lower subscript needs to be two parts. You're going to have a point, comma, some degree measure, which we call the magnitude, telling us how far to turn it. And then we've got the pre-image, and then we've got this rotated. How about I put the right word up here? Rotation notation. And so we really have two parts that we're looking at. What point are we rotating around and how far? This magnitude, which tells us the degree at which we are turning. So let's just take a couple of notes. Point. This is called our center of rotation. Right? This is where everything is being turned or pivoted around. So this is the center of rotation. Center of rotation. The magnitude, on the other hand, tells us the degree. How many degrees are we turning it? If I can spell correctly, it'll get there. Degree. Now, there is something unique about the degree measures. Because if you think about rotating a piece of paper, you can either rotate the piece of paper clockwise by turning it to the right, or we could turn it counterclockwise by turning it to the left. And so when we look at rotation and we look at these different notations, we have to remember this. Positive degrees of rotation actually mean to rotate the image counterclockwise, whereas a negative magnitude means to move it clockwise, right? So if we have a positive degree measure, we're going that way with the shape. If we have a negative magnitude, negative degree measure, we'd be going that way with our shape. Okay, and that all refers to this magnitude. So that's really, really important. This positive and negative magnitude. Now, what is preserved under rotations? Well, again, it's A, B, C, D. All of those things are still preserved. Angle measures, still going to be the same no matter what I rotate. The betweenness, the collinearity, and the distance. Those will all still be preserved. What we have to then look at is the orientation piece. Orientation will also be preserved in a rotation because we're not flipping the shape at all. We're just physically turning it. And so the way in which we travel around a shape, that orientation will still be the same. It'll make more sense when we get to our next slide. So here's an example, and what I'd like us to try and do from this example is write the proper notation for what's happening in this diagram. We've got this pre-image, XYZ, this triangle, and it's being rotated this way, 102 degrees, right? I know it's going this way because of the arrow. I also know that it's going this way because I've got my shape up here, X prime, Y prime, Z prime. X, Y, and Z prime. So we can slowly start to fill in some of these pieces. Okay, once again, let me just try and remind you of the formula. R of some point, comma, the magnitude, pre-image equals the image. So we're going to have a reflection. This reflection is moving around point A. You can see it because it's a point in the middle. You can see the angle that it's showing me the magnitude connects to the vertex at A. We've got 102 degrees. Now what we have to figure out though is, should that be a positive 102 degree turn or should that be negative? I'm going to go back one slide quick. All right. If I am going clockwise with my degree turn, if I'm going clockwise, I should have negative. Right? So we're going clockwise. This arrow is clockwise, so I better put a negative sign there. The pre-image was the triangle XYZ, so XYZ equals the rotated image, X prime, Y prime, Z prime. So you can see how we're just using the picture to come up with the notation. Being rotated around point A, it's going clockwise, which makes it a negative 102 degrees. So that's what we're going to put in there. The pre-image was XYZ. That's what we're starting with. The rotated image was X prime, Y prime, Z prime. And that's how we come up with that notation. Now the orientation, let me show you here on this diagram as we can talk about the orientation. If you look at the orientation, we go from X to Y to Z. So I am going clockwise, right? Just in that triangle, I'm going clockwise from X to Y to Z. If I follow that pattern, X prime, Y prime, Z prime, you can see we are also going clockwise. And that's why we say that orientation here is preserved. It's kept the same. It doesn't change like it did in reflections. The orientation is kept the same, or it's preserved. All right, here's our last example. We're just working on notations today. So what I want you to try and do is describe in words what is happening with this rotation. What's happening here? Pause the video, see if you can answer the question here on Edpuzzle. Okay, hopefully you might be able to tell us a couple of things. Okay, first of all, we start with the pre-image. ABCD is being rotated around point E 75 degrees counterclockwise. Counterclockwise, right? This positive 75, because it's positive, means I have to move everything counterclockwise around point E. Now, here's what that might look like, okay? This is not going to be the best example because, again, I don't have all of the drawing tools that I would need to make it fully accurate, but let's just start with this triangle and say this is A, this is B, this is C, and this is point D on our rectangle. Down here might be my point E. All right, so everything has to get rotated. If I drew this imaginary line, oops. If I drew this to point D, and I drew another one over here, this would have to be 75 degrees. Why did I draw it to the left? Because I know that my degree measure was positive, which meant counterclockwise, right? So point D would have to end up D prime right in that spot, and then everything else is going to get moved that same way, 75 degrees counterclockwise. But really, I'm hoping that you will be able to type in an answer like that. The pre-image ABCD is being rotated around what point? Around point E, 75 degrees, and then which direction? In this case, counterclockwise. All you've got today are 6 problems to try and practice this notation part. The notation is most important. Once we get that, we'll be able to draw and find some angle measures. If you have any questions, make sure that you hit me up. Otherwise, we'll see you next time. Stay safe.